let's graph polynomials. Remember when looking at end behavior, we said the odd degree polynomials will have opposite end behaviors, either starting low and ending high, or starting high and ending low. And even polynomials would have the same end behavior where they both start high or they both start low. Polynomial x to the third will look something like this. Starting low and ending high because it has a positive leading coefficient. That leading coefficient is now negative, so it's going to start high and end low. Similarly, x to the fifth, positive coefficient, so it will start low and end high. Will look something like this, changing directions 5 times. Negative x to the fifth will start high and end low. The evens then, something like x to the fourth, starting high, ending high, changing a leading coefficient to a negative, start low, end low. X to the sixth, positive, start high, changing direction 6 times, negative leading coefficient, start low, end low. With this knowledge and the knowledge of zeros, we can now sketch a graph. If I tell you that the zeros of a function are -2, 1, and 5, I want you to sketch this graph and write it in standard form. Remember to write it in standard form. I'm going to do x. What do I have to do to this -2 to make it 0? Add 2. And then to the 1, I need to take away 1 to make it 0. And then to the 5, I need to take away 5 to make it 0. Now you can see here that this is going to be third degree based on my 3 x's. Using my grid here, I'm going to go over to -2 as one of my zeros, 1 as one of my zeros, and 5 as one of my zeros. I see that all of my x's are positive, so that means I'm going to start low and end high. Here, when I plug it into my calculator, I can see that it's very similar to what I sketched, and the sketch is not accurate with my 0 at -2, 1, and 5.